welcome to your favourite teacher. Today we'll be looking at limiting reactants. All chemical reactions have reactants and products. Reactants are used to make products. If there are no reactants, then a chemical reaction cannot happen. This is linked to the idea of the conservation of mass. If one of the reactants in a chemical reaction is used up, then the reaction will stop completely. The reactant that is used up completely and stops the reaction from happening any further is called the limiting reactant. It's kind of obvious when you think about it. Another way of looking at the limiting reactant is the one that's used up first. The other reactants are then said to be in excess because they've not been completely used up. The reaction of sodium and water is useful to demonstrate this idea. When sodium is added to water, it reacts and produces sodium hydroxide and hydrogen gas. In this reaction, the sodium metal reacts readily with the water and makes a hydroxide in the water. The sodium metal will completely disappear. There will still be water in the container, which you test using an anhydrous copper sulfate. In this reaction, sodium metal is the limiting reactant, as once all the sodium has reacted with the water, there'll be no more gases given off. The bubbling will stop and the party is over. The reaction will have gone to completion. The amount of product formed is directly proportional to the amount of the limiting reactant. If you halve the limiting reactant, you'll halve the amount of product. If you triple the limiting reactant, provided everything else is still in excess, then you'll triple the product. This is because there are more reactants available to combine and form the new products. You can calculate the mass of a product that would be formed in a reaction by using the mass of limiting reactant and the balanced chemical equation. It's important that the equation is balanced before you start, as it will give you the ratios of each of the material. Next, you need to work out the number of moles. This involves using the MR, or relative molecular mass. Using the balanced chemical equation, you would then be able to work out how many moles of all the product could be made. You could then work out the theoretical yield of the product, the amount produced, using this information. Let's have a look at an example in order to demonstrate this method. What mass of magnesium oxide is produced when 40 grams of magnesium is burnt in excess air? First, we need to write out the balanced chemical equation, which for this reaction will be 2Mg plus O2 goes to form 2MgO. We know that magnesium is the limiting reactant from the question because, let's face it, we're not going to run out of air. Next, we need to work out how many moles of magnesium 40 grams is. To do that, we need the AR of magnesium and the MR of magnesium oxide. From the periodic table, we can see that the AR of magnesium is 24 and the MR of magnesium oxide would work out to be 40. We're going to substitute these values into the equation using these ratios to show how much would be made. So by filling it in, we can see that 48 grams of magnesium metal would make 80 grams of magnesium oxide. We then need to find out how much would 1 gram of magnesium make and use that information to find out how much 40 grams would make. To do this, we need to divide both sides by 48 first to see what 1 gram of magnesium would make. This shows us that 1 gram of magnesium would make 1.67 grams of magnesium oxide. We're then going to multiply both sides by the mass of the limiting reactant, which here is magnesium. So we're going to multiply both sides by 40, and we can then see that 40 grams of magnesium would yield 66.8 grams of magnesium oxide. You can be asked to work out which reactant is the limiting reactant when given the masses of both reactants. The first step with a question like this is to write a balanced chemical equation for the reaction. Next, you're going to need to work out the number of moles of each reactant. Then you're going to need to compare the number of moles of your reactants to the required moles for the reaction to occur. Are you still following? You can then use this information to identify the limiting reactant by seeing which one is less than required. It might be a bit clearer if we have a look at an example. So if you have 5.6 grams of magnesium ribbon reacting with a dilute solution of hydrochloric acid containing 8.4 grams of HCl, which reactant is the limiting reactant? First, we need a balanced equation for the reaction in question. This would be Mg plus 2HCl goes to form MgCl2 plus H2. From this, we can identify that we need 1 mole of magnesium for every 2 moles of hydrochloric acid. The next step is to identify how many moles of each substance we've been given in the question. And just for a change, we need to divide the mass of each of our reactants by its relative mass. To work out how many moles of magnesium we started with, we need to divide 5.6 by the relative atomic mass of magnesium, which is 24. This is going to give us a value of 0.233 recurring. Next, we need to work out how many moles of hydrochloric acid we started with. To do this, we divide 8.4 by 36.5, the MR of hydrochloric acid. This gives us a value of 0.23. We know from earlier that we need 1 mole of magnesium for every 2 moles of hydrochloric acid. So we need double the hydrochloric acid. Oh no! So the hydrochloric acid is the limiting reactant in this reaction and the magnesium is in the excess. Let's summarise. All chemical reactions have reactants and products. If one of the reactants in a chemical reaction is used up, then the reaction stops. This is the limiting reactant. The other reactants are then said to be in excess. The amount of product formed is directly proportional to the amount of limiting reactant. You can calculate the mass of a product formed in a reaction by using the mass of the limiting reactant and the balanced equation. You might also be asked to work out which reactant is the limiting reactant. I'm Miss Meeks and we've been looking at limiting reactants with your favourite teacher. Thanks.